This will be the second part of the lecture for Chapter 17 notes in AP Chemistry. We start this lecture with the solubility guidelines for common ionic compounds in water. We're going to have a quiz over the solubility rules in class as well. And we need to first distinguish between what we classify as soluble and insoluble compounds. We're going to use 0.01 molar at 25 degrees Celsius as our dividing line. Now some people use 0.1 molar solutions as the guideline, so you might see some discrepancies online if you see one solubility rule and another solubility rule. But anyway, what this means is that any salt that you throw into water that can reach a concentration of 0.01 molar will be classified as soluble, and if you can't get it as concentrated as 0.01 molar, then it's going to be insoluble. And the reason we do this is because very few substances have their maximum solubility near this cutoff point of 0.01. Now there is another classification of solubility as slightly soluble, but we're going to ignore slightly soluble compounds in this particular guideline overview. And so here are the rules for solubilities. If you're a group 1 metal, that's an alkali metal, that's lithium, sodium, potassium, rubidium, and cesium. We're not going to have to worry about francium because it's a radioactive group 1 element and it's very rare, so I wouldn't expect to ever see it on any AP test, and I'm not going to give it to you on a quiz. But anyway, anything in group 1 and ammonium ions, that's NH4+, are going to be soluble in water. No matter what negative ion they're hooked up to, they're going to always dissolve. And then all of these anions are going to be soluble no matter what metal they're hooked up to. So acetate, perchlorate, chlorate, nitrate compounds all dissolve in water. Now rule number 3 tells us what metals do not dissolve except if they're hooked up with an ion in group 2. So silver, lead, and mercury 1 compounds are insoluble unless, again, they're hooked up with acetate, perchlorate, chlorate, or nitrate. Rule number 4 states that chloride, bromide, and iodide compounds dissolve as long as they're not hooked up with the silver, lead, and mercury 1. Rule number 5 says that all carbonates, oxides, phosphates, chromates, fluorides, and silicate compounds are insoluble. Now, rule number 1 says that if you're in group 1 or ammonium, you would dissolve. So rule number 5 comes after rule number 1. So if you're like lithium carbonate or sodium carbonate, you would dissolve. But any other metal carbonate besides the one in group 1 and ammonium would be insoluble. So carbonates, oxides, phosphates, chromates, fluorides, and silicates are insoluble. Now, my class came up with a good mnemonic device for remembering these ions that are insoluble in rule number 5, and it's called CrO-CO copopho. CrO-CO copopho. And it comes from the formulas for the ions. So Cro is chromate, so it's CrO4, so it's Cro, and then CO is silicate, SiO3, so it's CrO-CO, and then copopho stands for carbonate, phosphate, and then fluoride and oxide. So Co is the carbonate, CO3, Po is the phosphate, which is PO4, and then fluoride and oxide would be F and O ions. So Cro, CO, copopho. I hope I said that right. But anyway, that's a little mnemonic device that my class came up with for rule number 5. So those do not dissolve in water. Now rule number 6 says that hydroxides and sulfides do not dissolve except for calcium, barium, and strontium hydroxides or calcium, barium, and strontium sulfides. Now this makes a lot of sense because we learned in an earlier chapter that calcium, barium, and strontium hydroxides are strong bases. So we would expect that their hydroxides would be soluble in water. And this is also true for their sulfides. So calcium, barium, and strontium sulfides would dissolve, but any other metal would not. Now again, if you remember up in rule number 1, it says that all lithium, sodium, potassium, rubidium, cesium, and ammonium compounds do dissolve. So that would usurp rule number 6. It would override rule number 6. The last rule talks about sulfates. Sulfates typically dissolve except for calcium, barium, and strontium sulfates. And of course, if you refer to rule number 3, silver, lead, and mercury compounds, they do not dissolve. So again, rule number 3 comes before rule number 7. So if you had something like silver sulfate, it obviously wouldn't dissolve because of rule number 3. Now, I explain this concept of the rules being applied in order in this bullet point. And I've been referring to it as I've gone through these guidelines. I hope it didn't confuse you as much as it may have sounded to my ears. But anyway, for example, it says lead sulfate is insoluble. Now, why is that? Well, lead sulfate is insoluble because of rule number 3, not because of rule number 7. In a likewise manner, you have silver chloride being insoluble because rule number 3 takes precedence over rule number 4. So you have to apply these rules in order. And we cover a lot of examples in class, and so the students are pretty good at remembering which compounds dissolve and which rule it refers to. So you need to apply these rules in order for them to be successful. And last but not least, these are just guidelines, so there might be some exceptions to these rules, but that's why it's just called a guideline. Now, there's a table format of some of these rules shown on this slide. I don't like this slide as much because it's not as in-depth as the previous slide. Now we talk about the precipitation of ions. So we can use our knowledge of KSP values in equilibrium to determine if you're going to make a precipitate. So here's a good example. If you have barium sulfate, it has an equilibrium with barium ions and sulfate ions. And at any time you can calculate the Q value. Now Q stands for the initial concentrations of barium and sulfate represented in an equilibrium expression. So Q uses initial concentrations of barium and sulfate, whereas K values use the equilibrium concentrations of barium and sulfate. Now we've had to calculate Q before in chapter 16 when we were talking about acid and bases, so the student should be again familiar with Q values. Now, if Q is bigger than K, you will be able to form a precipitate. If Q is equal to K, then you're at equilibrium. And if the Q value, again, which is the initial concentrations of your ions, if the Q value is less than K, well, you're not to equilibrium yet, so it can still dissolve, so you won't form a precipitate. Now, we're going to do a practice problem in a little bit, but I wanted to show you this idea called selective precipitation on the next slide. Now, you won't have to do any of this on a test, but it is something that's kind of cool. If you have all these ions mixed together, silver, lead, and mercury ions, and copper and bismuth ions, etc., you can actually selectively precipitate them in groups. You can get out the first 3 ions by mixing them with chloride ions. Now, you can get those chloride ions from hydrochloric acid, and then you can precipitate silver chloride, mercury 1 chloride, and lead chloride from that solution. The group 2 ions are insoluble sulfides if the solution is acidic, and so you can take those out of solution by mixing in hydrogen sulfide in an acidic environment. And then you can precipitate sulfides and hydroxides in that 3rd group, which is colored blue, and then you can precipitate the 4th group of barium, calcium, and magnesium ions as phosphate precipitates. And what you'll be left with is the sodium, potassium, and ammonium ions that are left. So that would be the alkali metal group 1 ions and ammonium ions. That refers to rule number 1, if you remember the solubility rules on the previous slide. Now, this is called qualitative analysis and quantitative analysis when you do these types of precipitations in college labs or even in high school labs. A qualitative analysis lab just asks a simple question: are the ions present in the solution? So you mix 2 solutions together. If there's a precipitate that forms, you can assume that there is the presence of that ion in the solution. A quantitative analysis lab would be, okay, if there are ions in the solution and you made a precipitate with them, how much was in the solution? So qualitative analysis just asks yes or no to the question of, are there these particular ions present? And quantitative analysis asks how much of those ions were present in the solution. The last slide basically deals with an example practice problem of will a precipitate form. So we're going to try to form the precipitate silver sulfate by mixing two solutions together. Now your solutions are silver nitrate and sodium sulfate. Here's your reaction that we're going to be concerned about. It's the silver sulfate equilibrium expression, and you can write it as products over reactants. Now again, there aren't any reactants that are aqueous, so we don't have to worry about the silver sulfate compound. So we just have the concentration of silver squared times the concentration of the sulfate ions. And the K value you can look up in the back of your book. It's 1.5 times 10 to the negative fifth. So if this silver concentration squared times the sulfate concentration ever gets higher than 1.5 times 10 to the negative fifth, it will form a precipitate. So we can easily calculate the concentrations of these ions in the solution. We calculate the number of moles, and we end up dividing by the number of milliliters total after they're mixed together. So you can calculate the moles by doing the molarity times the volume, and then you just need to divide by the total volume of the solution to get the concentrations. Once you have these concentrations of silver ions and sulfate ions, you can put those into your K value expression, but we're using these initial concentrations, so we technically should call it Q. You can calculate the Q, compare it to K, and see if it's bigger or smaller, and then you can decide if it's going to precipitate. Now the Q value ends up being 9.16 times 10 to the negative sixth, which is smaller than K, so you're not to equilibrium yet, so there aren't enough silver and sulfate ions to make a precipitate. So no precipitate will form. Now we do a solubility lab. We take a solubility quiz, and we have a lot of practice problems on the second part of this homework to get used to calculating Q, to see if a precipitate forms, and to calculate molar solubilities, and also to calculate the K values. So that's basically the information in the second part of Chapter 17.